So hello guys, welcome to AR Tutorials. Today is day 28 of solving Leetcode questions daily. So friends, as you all know that this part will be the continuation of the last part which I have covered on the binary search upper bound. So today we'll be completing the lower bound. In last lecture I have told you that what are the upper bounds and what are the lower bounds. So I hope you know what is the concept. So let me remind you what is the upper bound. So upper bound is basically involves what is the number greater than. So this is the upper bound, and whatever the number is, whatever the value inside my array, it checks it is the greater than equal to, it is the lower bound. And lower bound basically counts the first occurrences of the element, and which is that element. And what the upper bound does, if I have to count this element, that is number 3, the what is the upper bound of what is the lower bound of number 3 here in this array? It is 0 and 1. It returns 1 because it is the first occurrence, that is the lower bound. But what is upper bound? It ignores that number 3 and it tells the index of the higher values because it only consists of greater than. So it returns me 2 by 2 because 2 is the index of 5 and 5 is immediate greater than the 3 number. I hope you have understand. If you haven't understand, please comment it out. I am all way up to solve all your doubts. I hope you have got this. Nothing much, nothing fancy. So only this much. And I'll just tell you what is the upper bound right now inside the code only. So here we have to search the position. So while searching the position is not a very big task, but here is a twist that if the number is not present, we have to tell you the appropriate position where we have to do. Now why appropriate position? Just we'll think that if I have a search space, I'll just eliminate whatever elements I don't need. Then how can I know that if the element is not present, what is the perfect match for it? Obviously upper bounds and lower bounds, because we'll calculate what? We'll calculate the first occurrence. If the occurrence is not present, it will just tell me that this is the best place to insert it. And while using upper bound, we'll get the higher values we don't want. If it is equal, it will return that value. If it is not, it will return the immediate higher value where it should be placed. So what we have to do, lower bound or upper bound? Yes, it obviously upper bound, because we are searching that number. If it is present, we'll return. If not, we'll return the immediate highest one. So this I have told you this. So only one sign will change the whole code. Only one sign will make it upper bound or lower bound. Just these are the basic. Come on, if you don't know this, please watch my video. I have complete every single thing by low and high we'll take. So low and high we have taken. Answer is just a variable which I have declared, and I have assigned it 1 because if the values exceed, just we can return the size of the array. So what happens, we'll just traverse it, we'll calculate the mid and check if the number of mid, it is greater than equal to target. If it is greater than equal to, what means what? We have found that element, or we have the immediate next element which is appropriate for that position to be inserted. So we'll just put my mid, and we'll just reduce the gap because we know that from mid to high there is no space used because we are searching in the lower search space. So we'll reduce it, and we'll just now reduce, if it is not true, then we'll reduce the lower space, and we'll iterate over and over. This is not meaning that we are only iterating once and immediately reducing it half. No, we'll take the iterations, long iterations, and then we'll return our answer. So our answer is returned like this. And finally, we'll just discuss about the time complexity. You can do it in an iterative way, in a n square complexity, because you need one element, or using pointers also you can do, but we are using here big O of log n complexity. Why log n? Interviewer would be blown away if you know the log n complexity, why log n, this and that queries. If he does know, it is very important. So I personally feel that log n complexity. Why? Because we are exponentially reducing a search space. We are checking it. If it is there, yes. If it is there, then go for it. If not, just reduce the other half. No use of that. So this basically is that. And guys, if you really want to know the time complexity, I can take a very detailed lecture on it. Very detailed lecture. Almost I can cover all the concepts in half an hour. So please comment complexity. If you don't know complexities, I'll just teach you every single complexity types, how it is calculated and how it should look like. So thank you guys for watching this. But first I'll just run the code. I think it will run properly because we have passed all the edge cases. Yes, it has, and we'll just submit it. I think this is the most optimal code ever seen or ever asked by the interviewers. Though it has some types that it could be reduced in this and that way, but approach is the minimal one, and interviewer only wants the approach. So thank you guys for watching this video. I really hope you have liked this video. Please share and please please do subscribe to my channel. Thank you.